LeetCode 1717, maximum score from removing substrings. I haven't done this in a while, so I just recorded it. I'm recording after I've done the problem, but I'll just go through my solution and what I thought about how I thought through it. I did have to look through the hints because I've not done LeetCodes in a while, not properly at least. So the first hint was it's always optimal to take one type of string over another, which is a good hint because I was thinking of doing backtracking, which will just be a lot of options and a lot of complications for sure. In terms of decision, I think backtracking would definitely work, but in terms of joining strings would be a big pain in handling that. And the second hint was you can use a stack to handle erasures, which is a very good hint, very good thing to note about in terms of in this situation. Stacks was very useful. It's very easy in terms of string manipulation if you're removing a chunk out of it. So with this, with the first hint, and so it's optimal to take one substring over another. This is in relation to the fact that you can either remove substring A, B, or BA, and it'll either give you X points or Y points. And the fact that X or Y allows for variability, so either it's more points to remove AB or more points to remove BA. So with that in our code, that's where I do right here, where I select which substring has the most points, and that's whatever has most points is one we'll be removing, and I save that point as well right here, right? So if X is greater than Y, we choose AB because X is affiliated with X. So AB is affiliated with X, and then BA is affiliated with Y, and then I just save the number of points to add as well. So our stack and the number of points for the substring. So in this situation, let's say if X was greater than Y, we'll be only removing AB in the situation. So for every character in the string, I append the character to the stack. I make sure that the stack is at least length of 2, and I check if the top of the stack is B, and the second to last element in the stack is A. You have to do it in reverse because stacking it would be in reverse. Makes sense. If that's such as the case, that means we found a valid AB, we pop the 2, and we add those points as if we removed it. And that's all we need to do in terms of manipulating the stack. I'll explain this in a second, but what I do is then this count is only if I remove AB. Now I have to remove BA after removing all the AB here. So I run the algorithm one more time where I create the new string by just doing a join stack here, which is always optimal rather than joining new strings. Python makes it simpler, but under the hood, it's a lot more expensive if you keep on creating new strings. And then I set whatever points was the highest, I set that to 0 because now I only want to focus on removing BA, which I need to make Y the highest. So let's say X was the highest. Now I set X to 0, and then Y will be whatever points it was, and then run this again. So what this will do right here is that now it'll be forced to choose BA. It'll create the stack one more time and remove all the BA options, and it'll hit this point here. And because X was 0, it'll just return the points that it had there. It'll return to here, and then now this algorithm here will return the points as if it only was moving BA. This is a count of removing AB, and it returns, and that's the total count that we need. Sounds good, and I'll see you tomorrow.